Welcome to myprojectbazaar.com. Our product title is a single stage, single switch, soft switching, power factor correction, LED driver. Now we are going to discuss about our product abstract. In our process mainly we focused for DC load. DC load we have using the some application for the LED drivers. So we have our main objective was we are giving the input for the AC source. We are convert to the rectify the AC to DC, and then using the some using the full bridge rectifiers converting the process. We can using the MOSFET switch processing the converting full bridge converters. We are getting output for the 12 volt DC. We can using the application for the load for LED. So we giving the input for the 400 voltage AC and convert to the DC using the some switching pulses. Here we mainly using for the PID switching pulses after we getting the inverting the process. So this we having the switching device for that two type of the level of duty cycle pulses. Basically we are using the PID control switching pulses for the single stage switching pulse generations for LED drivers. Here mostly we are using the application for the converting the process. The converting main for using storage application for like LEDs, some DC load for the applications process. So here 400 voltage AC we going to the converting the process using the rectifiers. After that using some storage device, the battery capacitor based. After using the regulating format we have consumed the accurate level of the voltage 12 volt voltages. We are getting the output for the 12 volt DC output process. So mainly using the switching pulses for the PID controller of duty cycle based switching pulses. Now we are going to discuss about our product flow diagram in our process mainly for the using AC to DC source load connecting for the process. Here we give the input source for the AC source. So mainly using the 400 AC source, the single phase, we are going to the convert the process. So AC to DC we have first we have make the process for the rectifiers. So rectifier we may use for the full way rectifier, off way rectifier, and bridge rectifier. In real time they are using that rectifiers. We are using the half way rectifiers, bridge off to T cycle based the rectifier. After that we using the buck and boost converter. In this converter we mainly using for the some switching pulses. So we are using the MOSFET switch. Why we using the MOSFET? Because the MOSFET is the most efficient and a low level of the leakage voltage as controlling the process. So we using the MOSFET is a very efficiency level. So we using the pulse generator. Pulse generator means we getting the some off duty pulse generator based PID controller. We giving the switching pulses for the MOSFET switches. We are using in converter for off bridge rectifiers that converting the process using the MOSFET switch. After that we using the buck and boost, and then we go into the DC to DC converters. So level of the DC to DC we using the last finally we using the converter for the application for 12 volt maximum. The LEDs for 3 volt maximum we getting. So we resistor based load using the load connections we getting the output for the LED drivers. Last finally we using the LED for 12 load consumption DC output process. Thank you watching our video. Now we are going to discuss about our product running procedure. Here we are using the MATLAB 2013 version software and using a Simulink tool. Here we having the Simulink for library browser. We getting the each and every components from here, search getting for the here the Simulink and SimCap. So additionally we lot of library function here. So here this is our designing for the LED drivers process. So we giving the input just we all connections we done. After that we go into the iteration time setup and then running the process. So just running the process, we getting the output. We using the scope model for the output process. So I have using the scope for the this is level. So first I give the show that input AC source. So this is the AC input sources. After output for the LED drivers. So this is the LED drivers. So 20 volt DC for the LED drivers, and then finally for the current and the scope model for the AC source to DC source level for the current, and each and every block the LED drivers current and source IAB, IBC, ICL level for the source for the process. So we are connecting the last finally the load for the DC load. So getting the resistor based, we giving the some load connection for the assembling process. So in the design we are giving the AC input source, and then rectifiers, 4 bridge rectifiers. After that, 2 switch mode for the converting the process, and 1 switch for the boost and buck and boost converters, additional 1 switch for the DC to DC converting the process. Finally using the transformer we getting output for the DC source. So we can lastly finally add the DC load for the resistor for load. Here we using the finally this is the source code for the assembling 2013 versions software MATLAB.